behaves in ways that just, well, defy common sense.
Yeah, we're talking about the free electron. The electron when it's not bound inside an atom.
Right, the particle responsible for, gosh, electricity, magnetism, those old CRT screens. So much stuff.
It really is one of the most important particles we know. But figuring out its true nature, that wasn't simple at all. Took decades of really clever experiments.
Yeah, each one sort of chipping away at the mystery.
Exactly.
And that's really our mission for this deep dive. We've got this stack of sources here looking at the key experiments that uncovered the fundamental properties of the electron.
Right. The goal is to pull out the crucial insights. How did we figure out its charge, its mass, that really bizarre wave nature?
And its spin. Can't frig its spin.
Definitely not. So we're going to trace this whole scientific detective story. Some really ingenious setups involved.
Like shooting beams in vacuum tubes.
Right.
And suspending tiny oil droplets.
Yeah, and scattering electrons off crystals. Even that famous one where a single electron seems to go through two places at once.
And why should you, our listeners, care about experiments from, over a century ago?
Well, because these discoveries, they're the bedrock, the foundation of quantum mechanics.
Which explains the whole subatomic world. And that, in turn, underpins countless technologies you use every single day. Your phone, computers, medical imaging.
Absolutely. So let's maybe list the properties first, the things these scientists were trying to pin down.
Good idea. Okay, so first, were they actual discrete particles?
Then what was their electric charge? That fundamental unit, yeah. Is it negative? How much?
And their mass, this tiny value me.
Then came the really weird one. Could they also behave like waves? Like light does.
The wave nature, yeah. And finally, spin this idea of some kind of intrinsic angular momentum.
Exactly. Particle charge, mass, wave, spin. Those were the big unknowns.
And the first clues really came from those glowing vacuum tubes, didn't they? Way back in the late 1800s.
That's right. The story really kicks off with the cathode ray experiments. Scientists were seeing these mysterious rays coming from the negative electrode, the cathode, in these evacuated glass tubes.
When they cranked up the voltage?
Yeah, high voltage. J.J. Thomson's work, particularly around 1897, was absolutely key here.
So what were the rays actually doing inside these tubes?
Well, they traveled in straight lines, cast sharp shadows that strongly suggested particles.
Okay, makes sense.
But more importantly, they were deflected by magnetic fields. And the direction told them, okay, these things carry a negative charge.
And Thomson also used electric fields.
He did. He confirmed they bent towards the positive plate. So negative charge definitely locked in.
So negatively charged particles, got it.